All right, this is homework number 11. The first problem says find the sequence of partial sums, S1, 2, 3, 4, and 5. So to find the first partial sum, you just use the first term of the sequence. The second partial sum is the sum of the first two terms. The third partial sum is the sum of the first three terms. Now, you added the first two terms already, so it's really going to be 5/4 plus 1/9. Common denominator is 36, so this becomes 45 plus 4, so 49 over 36. The fourth partial sum is the first four terms added up. Remember, you just added the first three terms. And then add to that the next term, which is 1/16. Now you could do the common denominator is 36 times 16 and then probably reduce. I want the least common denominator, so I want to think about this. 36 is 6 squared, and that's 2 times 3, so 2 squared times 3 squared. 16 is 2 to the 4th power. So if we have these factors, what would our common denominator be? It would be 2 to the 4th times 3 squared, which is, what is 2 to the 16 times 9 is 144. So our common denominator is 144. What do we have to multiply each fraction by to get 144? Maybe you know that off the top of your head, but also just look at this. We have, this fraction has 2 squared, 3 squared. You need to multiply it by what it's missing to get 2 to the 4th, 3 squared. So we need to multiply 49 times 2 squared. That's what it's missing. So that's 196. And then the 1/16, the 2 to the 4th is what we have. We're missing the 3 squared, so we're missing a 9. And 196 plus 9 is 205. So that's where 205 over 144 comes from. And then finally, the fifth partial sum is the fourth partial sum plus the next term, 1 over 25. So let's see, can I do the same thing? We want to add 205 over 144 to 1 over 25. Now, these do not have common factors, right? This is just 144 is 12 squared and 25 is 5 squared, and they're not going to have anything in common. So this common denominator is 144 times 25. So again, I know we could use a calculator, but as I was working on this morning, I thought it's good for your brain every now and then to do this kind of calculation stuff and make sure you can still actually do it. Because it's very easy after you've been in high level math and not really doing all of this stuff to miscalculate all over the place. So 5 times 4 is 20. 5 times 4 is 20 plus 2. 5 times 1 plus 2. Placeholder 0, and then it's 8, 8, 2. 0, 10, 16. So that's 3,600. All right, so the 205 needs to get multiplied by 25. That's 2, that's 10. That's 1, that's 4. So that looks like that's 5,125. The 1 needs to get multiplied by 144. And do I get my answer here? 9, 6, 2, yep. 5,269 over 3,600. And let's see, does that reduce? These digits add up to 7, 13, 22. So it's not divisible by 9 or 3, or 2 or 10 or 5. So no, I don't think we have anything in common there. All right. And then I just listed out the sequence. So remember, we were coming up with a sequence of the partial sums. So the nth partial sum would have this string of sums so far. All right, let's do this. Next one is not quite as cumbersome, if I remember correctly. So, all right, what is the first partial sum? It's just the first term. The second partial sum is 3 minus 9 over 2. 6 over 2 minus 9 over 2 is negative 3 over 2. The third partial sum is that previous answer plus the next term, 27 over 4. So negative 6 over 4 plus 21 over, or plus 27 over 4 is 21 over 4. The fourth partial sum is the third partial sum minus the next term, 42 over 8 minus 81 over 8. So 81 minus 40 would be 41, and then we need to subtract 2 more, so that would be 39, negative 39 over 8. And the fifth partial sum is that previous partial sum, negative 39 over 8, plus 243 over 16. So this is going to be negative 78 over 8, over 16, I mean, plus 243 over 16. So yeah, sometimes I do this in stages. So 243 minus 70 would be 173, and then subtract 8 from that. So 173 minus 8. My brain just doesn't want to keep track of all this stuff. So that would be, 165. 165 over 16. Yeah, so then here's my string of terms for the nth partial sequence. Number 6, the same directions apply, but they gave you sigma notation. So the first partial sum with sigma notation, it would be n equals 1 to 1. So you don't have to write it like this. I just wanted, when I was doing the answer key, I just wanted to show you what that would mean. So this just means plug in 1 and that's it. So you get negative 1 squared over 1 factorial, and that's positive 1 over positive 1. The second term would be the sum from the first term to the second term of negative 1 to the n plus 1 over n factorial. So that's the previous one you just got plus the second term. So negative 1 to the third over 2 factorial. That's 1 minus 1/2, which is 1/2. The third partial sum would be the sum from 1 to 3 of this sequence. We already added up the first two terms and got 1/2. So just do the third term here. So plus negative 1 to the fourth over 3 factorial. So that's 1/2 plus 1/6. 3 over 6 plus 1 over 6 is 4 over 6, which is 2/3. The fourth partial sum, I wrote an infinity, I meant to write a 4, is the sum from 1 to 4 of negative 1 to the n plus 1 over n factorial. So the first 3 terms added up came out to 2/3. And then we add the fourth term. So negative 1 to the fifth over 4 factorial. That's 2/3 minus 1 over 24. This becomes, multiplied by 8, 16 over 24 minus 1 over 24. So 15 over 24. And that reduces by 3, so 5 over 8. And finally, the sum from 1 to 5 of negative 1 to the n plus 1 over n factorial. So the first 4 terms added up came out to 5/8. Add the fifth term in, negative 1 to the sixth over 5 factorial. Remember, I talked about in the notes that it's a good idea to memorize 1 through 5 factorial. So this is 120. 5/8 plus 1 over 120. Does 8 go into 120? Because they're both divisible by 4 and 2. So let's see. 120. Okay, yeah. So it goes in 8 times 15 is 120. So we can just multiply 5 over 8 by 15 over 15. So 5 times 15 is 75 plus 1 all over 120. 76 over 120, which is, I guess I divided by 4, right? If you divide by 4, It's the end of the day, so my brain has really lost most of its capacity. End of my day, anyway. Let's see. So this is, this is 4 times 19 is 76. So yes, I did get 19 over 30. Okay, lots of computation for those first few. So let's switch gears here. We have matching to do. Match the series of the graph with its sequence of partial sums. So remember, these are not the terms, these are the sums. And I'm looking at my choices here, and I'm noticing that not all of the terms of the series that they give us, not all of them are alternating, but this is alternating because it has a negative, and so is this, and so is this. And out of these options here, it's hard to tell if you don't see this first point, but A is alternating, gets small very fast. D is alternating. The terms are bouncing up and down like that. And F is alternating. So the question is, which is which? So I would begin by finding the first partial sum. Like, where does it have to start? Because it looks like D and F start at the same place, but A does not. So take a look at your choices here. So S1 for this first one. Oh, sorry. S1 would be when you plug in 0, by the way. The first partial sum is the first term in this sequence, and this one starts when n is 0. So it would just be 15 fourths. And 15 fourths is 3 and 3 fourths. So that's it right there. 21 is A. So now we're deciding between 22 and 23. It's got to be F versus D. So they both start at 17 thirds. So that's not all that helpful. But take a look at the R. In number 22, you're almost multiplying by -1. Negative 8 ninths is pretty close to -1. Whereas in 23, you're cutting 17 thirds in half each time. You're multiplying by -1/2. So for 22, when I multiply this by almost -1, I would expect like the second partial sum so you can find the first partial sum if you want. It's 17 thirds. And then the second partial sum would be 17 thirds. And then I would almost get back to, like when I subtract 17 thirds times almost -1, it's -8 ninths. Or sorry, when I add that, I'm going to be subtracting almost 17 thirds. So even though I started at a huge number, when I subtract this, I shouldn't be as far, I shouldn't be as close from 0. It's not going to come out to 2 point something. It's going to be something really small, practically 0 right here. So this one has to be D, because then when I find the third partial sum, I've got this thing that's close to 0. It's like -0 point, or it's +0 point whatever. And then you're going to add another 17 thirds times almost a positive fraction, like 8 ninths squared or whatever. So it is going to keep bouncing back and forth, but that first one is more of an extreme difference. Here, when you're cutting this in half, 17 thirds minus half of 17 thirds, you're not going to drop as far down. You're going to go from almost 6 to almost 3. So I feel like I did a bad job explaining that, but you could also take limits. Like these are all geometric, so you could also see what they add up to. And I think we're supposed to do that anyway. See what they add up to and see which one kind of matches that. Because see how this one is zeroing in on 3? This one is zeroing in closer to maybe 4. So we can kind of see that way too. Okay, pause on those. And what about the other ones? B, C, and E. B and E both start at 1, but C starts a little bit above 2. So let's look at these. 20 and 24, when you plug in 0, the first term is 1. So those are the two that we're going to decide between B and E. That means 19 has to be C. When I plug in 0, I get 9 fourths, which is 2 and 1 fourth. So that makes sense. So then what about these two? This one looks like it's approaching 3, and this one looks like it's approaching like under 2. So 2/3 to the n versus 2/5 to the n. You could find the sums for these. 20 is geometric. A sub 0 is 1. R is 2/3. So I'm going to get the sum of it's going to be 1 over 1 minus 2/3, which is 1 over 1/3, which is 3. So yeah, this one has to be adding to approaching 3 for the sums. So B is 20. And that means 24 is E. We could do something similar. A sub 0 is 1 over 1 minus 2/5. That's going to come out to 1 over 3/5, which is 5/3. So yeah, this is approaching 1 and 2/3 instead of 3. All right. I left my writing on here because I just wanted to explain what I wrote for these last few. So state the definitions of convergent and divergent series. So if a series converges, it means that the series has a finite sum, like you get a number answer for the sum. A divergent series has no finite sum. It just continues growing without bound. Describe the difference between the limit as n approaches infinity of a sub n equals 5 and the sum from 1 to infinity of a sub n equals 5. So the limit, the first one, means that the terms in a sequence are approaching 5, whereas the summation, the sigma, means that the sum of the terms are adding up to 5 in the long run. 82, you delete a finite number of terms from a divergent series. Will the new series still diverge? Explain your reasoning. So remember, the new series will still diverge because remember, that means that we have this sum that keeps growing without bound. Just because I delete a set number of terms, I could delete a million terms from that sum, but if it's growing to infinity, it's just going to keep growing. It doesn't matter if I subtract a bunch of terms off of it. You add a finite number of terms to a convergent series. Will that new series still converge? Yes, because again, we're adding a finite number. I could add a billion terms to a convergent series, and what I just did was add a finite sum to another finite sum. So that will result in a finite sum, which is a convergent series. Mixing stats with calculus here, a probability question. So they've given us this probability that a fair head occurs on the nth toss is just 1/2 to the n. Show that the sum from 1 to infinity of 1/2 to the n equals 1. So this is a geometric series. And I know it's a geometric series with a1 equaling 1/2 because it says to start at 1. And r is equal to 1/2. So the sum from 1 to infinity of 1/2 to the n has to add up to a1 over 1 minus a1. I'm sorry, 1 minus r. This is 1/2 over 1/2. And that's equal to 1. The expected number of tosses required until the first head occurs in the experiment is given by n times 1/2 to the n, the sum of that. Is this series geometric? That's no, because n, we can't have a variable in front to have it geometric. This could be a constant. If it said like 5 times 1/2 to the n, that would be geometric, but we can't have another variable in front. It's not in the correct form. Another way to verify that, if you expand out the terms, you're not going to get a common ratio amongst the terms. And last question, find two divergent series, sum of A and sum of B, such that we add the sequences together and the series converges. I'm sure there are other examples, but I just thought like if you come up with any opposite number sequences, those would work. Like if I just tell you to add up -1 infinitely many times, that's a divergent series. And same with adding a +1 infinitely many times, that's a divergent series. But when you add these two terms together, you're really getting a sum of 0. So add 0 up a bunch of times, that converges. That's a convergent sequence that comes out to 0. So there are probably other examples. You could probably use just -x and x. But yeah, either way, I'm getting it to add up to 0. All right, that finishes out assignment number 11. Please let me know if you have questions.